Hello, everybody. So our next lesson on it's very similar to 10.1 where we used the slopes of parallel lines. Now we're going to look at slopes of perpendicular lines and how that will help us with proving that figures are maybe rectangles or squares, or maybe proving that diagonals are perpendicular. So we have talked about perpendicular slopes a little bit in the past. Let's go ahead and turn your books to page 509. And it starts off with a little bit of review in this statement. Now, we have said all along that two lines are perpendicular if their slopes are opposite reciprocals. So, for example, 2/3, and the opposite reciprocal would be -3/2. And so if you take a fraction and flip it upside down and change the sign, we've said that will give you perpendicular slopes. Now, they state it a little bit differently here. They say that two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So we can see that that actually works. If we multiply these two numbers, a slope and its opposite reciprocal, look at what happens. We get -6/6, which is -1. So that's another way that you can tell if slopes are perpendicular, is by multiplying them and see if their product is -1. So product, remember, means multiply. So we multiply the slopes. If we get -1, then we know they're perpendicular. Okay, so now we're going to jump forward to page 511 and take a look at example A, 1A. In this example, this figure looks like a rectangle, and we can prove that it actually is a rectangle by looking at the slopes. So the slope of side AB goes up 3/6, so that's a slope of 1/2. And the side next to it, side BC, has a slope of -2. And so we see that those two numbers, those two slopes, are perpendicular, because if you multiply 1/2 times -2/1, you do get -1. So that shows that those slopes are perpendicular. And same thing with the other pairs of sides. And so that's what they're showing here, that if we multiply these slopes, we get -1, -1, -1, -1. So that actually gives us 4 right angles. If the lines are perpendicular, that means they form right angles. And so that's enough to prove that this figure is a rectangle. Once we know that we have 4 right angles, we're done. We know it's a rectangle. So that one was completed for us. So now I'd like you to try this one, number 5, which is on the bottom of page 512. So please pause the video and everyone try number 5. And then after about maybe 4 minutes, 5 minutes, then press play and you'll be able to check your answers. Okay, so you can see the work I did here. I found the slope of all 4 sides. So the slopes are 3/2, -2/3, 3/2, and -2/3. And when we multiply the slopes that are right next to each other, multiply these two, multiply these two, multiply these two, and multiply these two, they all turn out to be a product of -1, which means all the adjacent sides are perpendicular. And so that means angle G, angle D, angle E, and angle F are right angles. So DEFG is a rectangle. And that's all you would have to show to prove that DEFG is a rectangle. Okay, so then going on to the next page. In this example, they give us a bunch of equations of lines that match the streets on a grid. And so they give us basically the equations of these four streets up here in the table. And so we can use the slopes to find out if the lines are perpendicular or not. And so usually to find the slope, you want to have the equation in the form y equals mx plus b, because the number in front of x tells us the slope. And so for this first equation, we would want to get y by itself. So you have negative x plus 2y equals 4. We want to get the y by itself. So first I add the x to both sides. So that would give me 2y equals x plus 4. So I added x to both sides. And then we would divide both sides by 2. So that means I'm going to divide everything by 2. That gives me an equation 1/2 x plus 2. And so this is what we're interested in. So we're going to write it right here. The slope is 1/2. Okay. And then you would do the same thing with the second equation. You could easily rewrite this one as y equals negative 2x plus 7 by if we could just subtract 2x from both sides. And so that gives us a slope of negative 2. And then for the third one, if I just divide everything by 2, I would get y equals 1/2 x minus 3. That has a slope of 1/2. And then the last one, all I have to do is subtract 8 from both sides. I get y equals negative 2x minus 8, and that has a slope of negative 2. And then we see again, if I multiply these two, I get negative 1. Multiply these two, I get negative 1. Multiply these two, I get negative 1. All the angles are right angles. And so we know for sure, since all these angles are right angles, then this grid of streets would give us a rectangle. So it says, classify the quadrilateral bound by the streets. In this case, it is a rectangle. Okay, and now go on to page 515, problem number 7 at the top, very similar to the one we just did. Go ahead and work as a group to rewrite all four of these equations and write down what the slopes are and decide what kind of figure is this. So pause the video, please, and give about maybe 6 minutes, and then make sure all the groups have discussed, and then press play to show the solution. Okay, so I rewrote all four of the equations in the form y equals mx plus b here, and then we looked at the numbers in front of x to get the slope. And notice that these slopes are not perpendicular. When you multiply 2/3 times negative 3, you get negative 2, not negative 1. So these do not form right angles. So this can't be a rectangle, but our opposite slopes, if we drew a diagram, our slope here is 2/3 and our slope here is 2/3, and our slope here is negative 3 and our slope here is negative 3. So those are not perpendicular, but the opposite sides have the same slope, so this must be a parallelogram. So the quadrilateral is a parallelogram. And that is it for today's notes. Everybody have a great day.